So today we're going to be solving integrals using substitution. And I'm going to show you the 7 steps that I use to solve these equations. For the first step, I put the equation into the integral times dx. And then for the second step, you make u equal to what's in here, but you pick what you want to set as u. And then since u is interchangeable with x, you can use the u equation to find x, but that's only in certain problems that you solve for x. Then you take the derivative of u and place it here. Then du equals the derivative of u times dx. Then you would solve for dx, which equals du divided by the derivative of u. And that's how you solve for dx. For step 3, you then substitute u and du into this equation. And then for step 4, you can pick one or all of these depending on the question you have, which is you would simplify, rearrange, or pull out a constant. This is all to end up with u and du by themselves. For step 5, you integrate. For step 6, you simplify once you're done integrating to make step 7 easier on you. Then you plug in u and then add c if there are no bounds. So for example, for number 1, it's the integral of x over x squared plus 5 times dx. So for step 2, you would pick what you want to set as u, and I'm going to pick x squared plus 5. Then I have a shortcut where I solve for x times dx and set that equal to, because solving for x and dx takes a pretty long time, so I just like this shortcut that I use. So then you would solve for du, taking the derivative of u, which is 2x, times dx. Then to solve for x dx, you would just divide the 2 on both sides. So you're left with x times dx equals du divided by 2. For step 3, you then substitute u and du back in. But first, you want to, I'll put x times dx so you can see how this works. So x times dx equals du divided by 2. So x times dx times 1 over x squared plus 5. When you plug in u, you would have du divided by 2 times 1 over u. For step 4, you then simplify, rearrange, or pull out a constant in order to get du and u by themselves. So I'm going to pull out 1/2 to get du by itself and u by itself. 1 over u is the same as u to the negative 1. For step 5, you integrate. The integral of u to the negative 1 is ln u. So you would be left with 1/2 du times ln absolute value u. For step 6, you would simplify. In this case, you don't need to simplify, so it would just be 1/2 times ln u absolute plus c. Because there are no bounds, you would just add c. So now you plug in u. So you'd be left with 1/2 ln u, but you would plug in, so it'd be ln x squared plus 5 absolute plus c. And this would be your final answer. After these 7 steps, they're pretty generic, but I would solve for x dx just to skip doing these individually and just do it all in one step, which makes it easier for me when I'm solving.